Okay, everybody say hi, Josie.
Hi, Jose.
Hi, Josie. 3-1 is quadratic functions. I love this chapter. This is one of my most favorite chapters to teach. So please share my enthusiasm. It makes sense. There's a lots of steps to each thing in this chapter, but I like it. I like it a lot. This is quadratic functions, okay? Just wait. We'll get to that. Just wait. We'll get to that, okay? Quadratic functions. This is 3-1. We will have a worksheet for homework, and I'll explain that here in a second. But let's talk about quadratic functions for a second. The parent for a quadratic function, write this at the top, is y equals x squared. Okay, y equals x squared. And the graph of him is a parabola. We know that, right? Yeah, we know that. Okay, now, most of the time you will not see just y equals x squared. You'll see something like y equals ax squared plus bx plus c. And what those numbers a, b, and c are doing, and actually a, b, and c are numbers, right? Yes. They're plugging numbers in for those. These numbers are going to change your graph and move him left, right, up, down, that type of thing, okay? That's what does that, okay? And we're going to be studying these functions. This is in standard form. Okay, standard form is ax squared plus bx plus c. Standard form, okay? Now, if they do not give you a number in front of the x squared, like this number right here, if they don't put a number there, what do you assume that number is? 1. Put that down. 1. If there's no number there for the a, you put a 1. Okay? It's just x squared, then it's a 1x squared, right? Okay? All right, we know that the graph of a quadratic function is called a parabola. Okay? We're going to graph our first quadratic function, which is this guy, and we're going to do that by making a table, okay? And making a table is kind of a pain in the butt. Typically, we don't want to make a table. And so we're going to graph this by making a table, but then we're going to learn some shortcuts down below, okay, to graphing this thing without having to make a table. So let's do what they want us to do to start with. We're going to graph using a table, and we're going to plug these guys in. So help me out here. We're going to plug those guys in. For the x's, so 3 times 0 squared minus 12 times 0 plus 6, and you guys are yelling at me saying it's 6 because those go away, and the f of x, or the y value, is going to be 6, yeah? But then what do they want in this third column? Or this? 6. They want us to like write it as an ordered pair, 0, 6, right? Plugging 0 in, we get 6 to pop out, makes sense, yeah? Okay, now I'm going to plug in the next one. The next one is 1, so 3 times 1 squared minus 12 times 1 plus 6.
3.
Okay. Yeah, not quite.
Not 3.
Not 3. It is negative 3 if you plug it in and you like solve that stuff. Negative 3. So that is the coordinate point 1 comma negative 3. All right. Now we're going to plug 2 in. And 3 times 2 squared minus 12 times 2 plus 6. And you got negative 6. Great. Okay, they're doing all this work for us, which is fine. I'm great with that. 2, negative 6. Okay, it is, because I remember. Okay, now 3, we plug 3 in, so 3 times 3 squared minus 12 times 3 plus 6. It's not negative 6.
I see how this is going.
9, 27.
Yeah, it is right.
Negative 3. Okay, now at this point, this is 3, negative 3. At this point, I can kind of see what's happening. Look at these y coordinates. We're up at 6, then we go down to negative 3, then we go down to negative 6, then we go back up to negative 3. Then what's going to happen?
Negative 6.
We're going to go back up to positive 6, right?
Yeah.
You see that?
Okay.
So this last point is going to be 4, 6, because you can see it's like doing that parabolic pattern. It's going down and then coming back up, all right? So we're going to plot those points. 0 is at 6. 1 is at negative 3. 2 is at negative 6. Let me go back. Negative 6. 3 is at negative 3. 4 is at positive 6. And that's what my parabola looks like. It kind of looks as though he is vertically stretched. Does it look like he's vertically stretched?
Yeah.
Do you know why he's vertically stretched?
No.
Because of that 3 there. That 3 is going to make him taller and skinnier, right? That 3 is a vertical stretch,
Yes.
right? So it's going to make him tall and skinny, okay? So that's what's happening there.
Kind of like correct.
That vertical stretch.
You're like crazy.
Okay.
Yeah.
What?
We talked
What?
about this
Is
morning,
Craig
actually.
Collins skinny?
Oh my goodness.
We actually talked about that in 4th period. We're doing
Yes,
we're
it was
doing
so
stretches
annoying.
and compressions.
I was trying to do the test today and
Yeah.
one cent. Guess what
This
I
guess
kept on hearing
antagonist.
chanting of? Kinda like Craig.
Kinda like Craig. Yeah. Anyway, okay. Now, down here they start to talk about two things that like are qualities of a quadratic function, and they are called the axis of symmetry and the vertex. So I'm going to go up to here and I'm going to show you what these are. Okay, the axis of symmetry, S-Y-M-M-E-T-R-Y, is called the AOS. That's how I refer to him because I'm too lazy. AOS is the axis of symmetry. AOS. Okay? Now, the axis of symmetry is that dotted line that goes straight down the parabola that makes him fold in half. Okay? So he is right here. This is my axis of symmetry. Do you see that? It's like where you're folding across. It's like that line of reflection, right? The axis of symmetry. Okay, now, the axis of symmetry, if we label him, what's the equation of that dotted line that I just put on there? X equals 2, right? Okay, I'm very picky. Make sure you include the x and don't just put 2. Okay, x equals 2. Make sure you have x equals 2. And then there's another thing that they talk about, which is called the vertex. Vertex. Have you heard of vertex before?
I did.
The vertex is this guy right here. It is 2, -6. You are correct. Okay, now, true or false?
True.
The axis of symmetry always goes through the vertex. True or false?
True.
False.
It's false.
True.
Does the axis of symmetry always go through the vertex?
True.
Yes.
I was right the first time.
Yes, it does. This axis of symmetry, this line always has to go. Listen,
I said true, then you made me
Okay,
question myself.
you were guessing. The axis of symmetry has to always go through the vertex. Okay, so check this out. Watch this. This number and this number will always be the same number. Does that make sense? That 2 and that 2, those will always be the same as each other. Okay? They won't always be 2s, but they will always be the same as each other. Does that make sense? Okay? All right, same as each other. All right, let's go down and talk about anything else that they say for the axis of symmetry and the vertex. Here we go. Axis of symmetry is a line through the graph of a parabola that divides the graph into 2 congruent halves, like folded across each other. Okay? And then the axis of symmetry will intersect the parabola at only one point called the vertex. Okay? Whatever. All right? Now, that vertex, let's say you have a parabola that's a smiley face. Okay? Your vertex is going to be a low point called a minimum. The paper's on the table. Grab one. Have a seat and be quiet. Minimum. Minimum. Okay? Who took 2?
Bud can share with me.
Did somebody take 2? I should have.
Bud, you can share with me. Bud.
I should have another
Come
one.
here, Bud.
Why don't I? I don't know.
Did you do your math wrong?
No.
You sure you didn't do your math wrong?
Okay.
I don't know.
Best friends stick together.
Carson, just sit tight and pay attention. Okay? All right, now the next one. If your parabola looks like this, your vertex will be a maximum. Okay? If your parabola is a smiley face, it will be a minimum. If your parabola is a frowny face, your vertex will be a maximum. Now, how do you tell, given an equation, whether it's going to smile or frown?
Negative and positive.
Negative or positive. I look at, so like let's say I'm looking at this function right here. How do I tell whether that is going to smile or frown?
If the negative is in front of the x squared.
Yeah, you look at what's in front of the x squared. Only what's in front of the x squared. Is that a positive number or a negative number?
Positive.
It's a positive. So this guy is going to smile. He's going to have a minimum. Yeah? Does that make sense? Okay, he's going to smile. Okay. All right, so let's move on down here, and they say that they want us to find 3 things. They want us to first find the y-intercept of that function. The next one is the axis of symmetry, and the next one is they say the x-coordinate of the vertex. I'm going to change the instructions, and I'm going to say the entire vertex, because we can find the entire vertex. Okay, the entire vertex, and I'm going to put that here. Here are the 3 steps. Okay, this is exactly like what one of your homework assignment is going to be. It legit has an ABC just like this. Okay? Exactly. Well, not the same problem, but anyway. Okay, same stuff, all right? The y-intercept. How do you find a y-intercept again? 0 for x, right? We plug 0 in for x. We learned that last chapter.
It'd be -3.
Okay, 0 in for x. So 0 squared plus 4 times 0 minus 3. Those zeros go away. So the y-intercept is -3. Okay, happy with that?
No.
All right, I'm going to skip over the axis of symmetry.
Why?
And we're going to go to the vertex next. Okay, this is the order that I do it in. Here we go. Ready?
Wait. Can you, like...
You need to write faster and pay attention.
This is coming.
Okay, what?
Did we get our test back or not?
Yes. You're going to have to wait, though.
Gone.
Okay, vertex.
I got a 98.
I'm not pausing class so you can look at your test.
What did you get?
Okay?
99.
All right, next thing. For the vertex, this is the thing that you're going to have to memorize and remember. Are you listening?
No, you're right.
Memorize and remember. This formula, you're going to have to remember this.
Oh, wait.
To find the vertex,
X.
the formula is -b over 2a. Okay, that's how you find the vertex. -b over 2a, -b over 2a, -b over 2a, -b over 2a. Remember that. Okay? That's how you find the vertex. Okay.
Yeah.
-b over 2a. Now,
What is B?
that's what we're going to talk about. We're going to talk about that. Okay?
Come back.
Over here in this function, ready? A is this number, B is this number, and C is this number. Okay?
A.
Now, what? There's no number there for A. What is that number?
1.
1. B is
4.
4, and C is
3.
-3. The negative goes with it. Okay? So let's write that down over here. For the vertex, we have A is 1, B is 4, C is -3. Those are the things that we have. Now, we really don't care about C in this case, but I wrote it down anyway. We need to calculate what -b over 2a is. Okay? -b over 2a. So, -b is 4 over 2 times a, which is 1. Do we see what I just did?
-4 over 2.
Okay? So that is -4 over 2,
Would be -2.
which is -2. Okay, now, hold on just a second.
That's only one.
-2, that's only one thing. When we're finding the vertex, we said that this was a smiley face, right? When we're finding the vertex, we need to find like an x and a y, right? We just found -2, and that's the x.
We just found the Y too.
How do we find the y?
Plug it in.
Yeah, we're going to plug it in. So, to find this guy, we plug in the x value. Okay, so my function was
Makes sense.
-2 squared plus 4 times -2 minus 3. We're plugging that -2 in.
Negative
Up here.
7.
Okay, hold on.
-15.
No, it should be -7.
I said -7. Caitlin,
-7.
Excuse me.
Okay?
Caitlin said
Isaac Mackin, go sit at my desk. Right now. Go. Because you cannot refrain from turning around and talking to everybody else. Go sit. This chapter is like, there's too much information in this chapter for you to screw around and miss something. Okay? Especially on the first section. Because if you're lost now, you're really going to be screwed. Okay? So,
I see what I did wrong.
-7. We just plugged that in.
Yeah.
We plugged in -2. How did we get the -2 again?
Negative B over
-b over 2a gave us that -2. Then we plug the -2 in and we get -7. This is my vertex. Okay? All right, so here we go. This point right here is -2, -7. Okay, now let's talk about the axis of symmetry.
-2.
The axis of symmetry is going to go through here, right? And what's the equation for the axis of symmetry? X equals -2. I'm going to be really picky. Make sure you put x equals on that, right? X equals -2. Yeah? Okay. Woo, that's a lot of information. So we found the y-intercept was -3. The axis of symmetry was x equals -2. And the vertex was -2, -7, yeah? Okay, now, part B says, make a table of values that includes the vertex. We're going to skip part B. And on the homework assignment, you're going to skip part B also. Because we have found shortcuts, and we no longer have to plot a bunch of points. We have found shortcuts, we don't have to plot points anymore. So we're going to go straight to part C, which is on the back side, unfortunately. But you guys stay on the front side and help me write this stuff down. What was the y-intercept again?
The Y-intercept was
-3, okay. The AOS was
-2.
x equals -2, okay. And the vertex
-2, -7.
was -2, -7. All right, now you go to the back side and copy this down. Okay, then we're going to plot him and we're going to graph, and that's it.
I was on the front side because Y-int AOL
y-intercept, the axis of symmetry of the vertex. Okay, for the y-intercept, that means he's intersecting the y-axis at -3. So there he is, right there. Intersecting the y-axis at -3. Okay? The axis of symmetry, x equals -2 is that dotted line that goes up and down, but we're at -2 on the x. So here is your AOS. Okay? And then the last thing is that the vertex is at -2, -7, right there. Okay? So this is the information that I have now. Yeah? And now I have to make him into a parabola. Okay, but I only have 2 dots.
That's easy.
Yeah, that's easy, right? We know how to do this, okay? So if this is a parabola, then, and that axis of symmetry splits him exactly in half. Check this out. This dot right here is 2 units away from my axis of symmetry. He's going to be the same on the other side, so he's going to be 2 units away over here. Same thing, right? He's like mirrored. So now I know what he looks like, and he's going to look something like this. Right? That's what my parabola looks like. Happy with that? I'm going to erase my dots here. Oh, I'm going to erase my dots here. There and there. There you go. Okay? What's up?
I already did part B before you started on part A.
Oh, darn it.
I
That's
just
okay.
did the equations.
Very good. Right, that's fine. That's all right. Okay? So there's that. Good?
I had all
Okay, the next thing is going to talk about maximums and minimums. And we already kind of talked about this already. This problem that we just did has a what?
Minimum.
He has a minimum. Okay, now, he has a minimum, but now we have to decide where the minimum is at. He has a minimum at what? Now, when we're looking for the minimum, we're only looking for the y-coordinate. Like, how low does he go?
-7.
So he has a minimum at -7. We only care about the y-coordinate. Okay? So that's what it says over here. The y-coordinate is either going to be a maximum or a minimum. Circle that. Only the y-coordinate. Okay? Only the y-coordinate. It's saying how high does it go or how low does it go? Right? How high or how low? Okay? All right. On your homework assignment, you have 2 different types of problems. And this is the first type. We're not done yet. This is the first type. Okay? Problems number 1 are going to be exactly like example 2. That's the first type of problem that you have. Okay? The second type of problem involves maxes and minimums, and this is the second type of problem that you will have, right? The type number
And there's
2.
only 2?
There are only 2 types of problems on your homework assignment. Type 1 and type 2.
Oh, that's not bad.
Not yet.
It's not bad.
Type 1 and type 2. Okay?
Not bad.
Now, type 2, this is example 3. Here we go. The maximum and minimum values. So let's look at this guy. This is my function right here. Find him, circle him, so you can see him. Find your function, circle your function, so you can see him. Next, it says, determine whether the function has a max or a min. Before we do that, is he going to open up or down?
Down.
How do you know he opens down?
Because of negative.
Because it's negative. You're right. Opens down. Is he going to have a max or a min? He's going to have a max, so we're going to circle the word maximum. Or you can write it down, maximum. He's going to have a maximum point. He's going to have a high point. Okay? Now, this is my maximum. What's another name for that maximum point? The vertex, right? So, on part B, where it says find the value of the maximum, it's just saying find the vertex.
Yeah.
Okay, find the vertex. So, and Reese just said, what's the equation for finding the vertex? Negative b over 2a. So let's list out a, b, and c for this function right here. Okay?
When you say Reese, you probably might.
I know, like you're just getting credit for things that you do not contribute to, right? Reese, Moana. I should.
Reese.
Oh, I found it.
Both look at it.
Yeah,
Every time I do
Reese.
it.
Well, duh, 'cause it's her name. What?
What's what?
All right, moving on. A, B, C. What is A? Oh, I don't want to write them like that.
It would be positive.
A equals, B equals, C equals. I don't want to do parentheses. Okay? All right, so looking at this function. Carson, what's A for this function right here? Carson Goulter, what's A? What's A for that function? This way.
He wasn't here for this.
Carson. Reese. Reese was here. Reese, what is A for this function right here? What's A? If you had to guess, we have an A, a B, and a C. What's A? No.
Hey, Reese.
That narrows it down.
Out of 3 of them?
Yeah, which one's A?
-4.
Easy. -4.
Oh my gosh, great. Hey, Carson,
No.
save yourself here. What is B gonna be?
A, B, C.
-12.
No. What? Is there a negative in front of that 12, child?
I'm in 12.
12. Okay, Isaac Mackin, who thinks it's funny back there? What's C?
-4.
What?
18.
18.
-4.
18 is C. All right, let's do negative B over 2A. So, negative B
Negative 12.
would be negative 12. Okay, hold on just a second. Wait a second. Okay. Just for example, what happens if your B instead was negative 12? How would we
You
do
would change
negative
You
12.
B?
would put 12.
You'd put a
It
positive.
would be like negative 12, which would be positive 12, right? Does that make sense? Okay, so there's that. All right, so negative 12 over 2 times A, which is
-4.
negative 4. Okay, now
24 is the answer.
negative 12 over what's 2 times negative 4?
-8.
Negative 8. The two
Where's the
negatives will
negative
cancel.
from? Oh, it's
The
negative
two
B.
negatives will
Gotcha.
cancel. What's 12 divided by 8?
1.5.
1.5. Okay, but that only gives me the x coordinate, right? How do I find this y coordinate? Plug 1.5 in for x. Okay? So, negative 4 times 1.5 squared
1.5.
plus 12 times 1.5 plus 18.
2.25, man.
All right, yeah. 1.5 squared is 2.25. What is 4 times 2.25? What's 4 times 2?
8.
8 was 4 times a fourth.
Not 9.
1. This is negative 9, yeah. What's 12 times 1.5?
6.
12.5.
18.
8.
Plus another 18.
27.
This is 27. Huh. 27. Yikes. Yikes.
That's, we would never be able to graph that.
1.5 comma 27. That's what he looks like.
Do we have to graph this?
Yes, we do. Okay,
No,
now,
you don't.
to graph this, here's what I want you to do on the graph. I'm going to move the x and y axis like over a little ways. So do that, x and y axis. It doesn't have to be in that spot, but it's kind of like the x and y axis are over in that corner. Here's your y, here is your x. And the y's, we're going to go by 2's. So I have 2, 4, 6, 8, 10, 12, 14, 16. You're not listening. 28. And it's at 1.5. We're going to go by 1's on the x-axis. 1, 2, 3, 4, etc., right? Okay? So 1.5 comma 27 is going to be that little dot right there. You're going by 2's on the y-axis and 1.5 over. Okay? And that's my dot. That's the vertex.
Then it goes down.
Okay? And then it goes down from there. But we don't know how much he goes down or what way. Can we do something else really easy, really quick to get another point for my graph? What do we got? What can we do?
Don't know.
What can we find really easily from that graph or from this equation? That gives us another point on my graph.
Something intercept, I forgot what it was. X-intercept or
The
Y?
y-intercept.
Yeah, the Y-intercept.
I got 2 hands.
Okay, the y-intercept is going to be
0. Or not. You gotta put
18. The y-intercept is going to be 18. Okay? All right, so y-intercept is 18 over here, and he's going to be 18 over here also, so this is what my parabola is doing. Okay? All right, we haven't answered the question yet, though. State the maximum value. What's the highest value?
Negative or 1.52.
The max is at, but we only care about the y-coordinate.
27.
So the max is at 27. That's what we want right here. The max is at 27.
Domain and range.
Okay? State the domain and range. Last thing.
So the range would be.
Okay, hold on. Domain and range. Let's talk about those. Domain is the x's, and the x's go
All
Right and
domain.
left and right.
Yeah.
Reese, you're gonna get kicked out of here if you don't keep your hands to yourself. You learned that in kindergarten. Let's figure it out. Left and right, the x values, domain. So going left and right, will this graph go forever to the left and forever to the right?
Yes.
Yes, right? You see the arrows? So the domain is
All real numbers.
all real numbers. The range is the y values, and the y's go up and down. Okay?
Anything less than
Will this graph go up forever?
No.
Will it go down forever?
Yes.
Yes. So we're only talking about the y's that are
Less than 7.
less than or equal to
27.
27. Is it equal to 27?
Yes.
Yes.
Yes, because it's touching 27 exactly. Do you see that? That maximum point, that's where your domain will be, right? Make sense?
Yeah.
Good? All right, I'm going to give you your homework assignment and then I'll explain to you some of these instructions.
Like, do we just do all of like either odds or evens?
Why do this?
Oh, okay, thank you.
I need two sets.
Oh, let's go! We got a worksheet.
I'll be gone.
She already said we had a worksheet from me.
Oh.
Let me go back to it. Mackenzie, hold on. Yep, hold on. Domain and range, there it is, right there.
Is it come quick, I get worksheet? I think I know what to do.
You gotta wait for her to get done.
Exactly.
Okay, Reese, that's another thing. Hands to ourselves, and why are we out of the chair? Because you're like running around the room. No, like if you have to throw something in the trash, get up and blow your nose, sharpen your pencil. Otherwise, you sit. Okay?
Summon the demon.
Because you distract others when you stand up and walk around. Okay?
Is it
All right.
always
Moving on to the homework assignment. Skills practice. Circle these.
Is it always negative?
Skills practice. Circle these. 1, 2, 3, and 4, 6, 8. 1, 2, 3, and 4, 6, 8. But stay on that side because we're going to look at the instructions together. Here we go. 1, 2, 3, 4, 6, 8. Part A says find the y-intercept. Make sure you do that. Write the equation of the axis of symmetry and find the entire vertex. Okay, not just the x-coordinate of the vertex, find the entire vertex. Yeah? If we do those things, make a table of values. We can skip over that. Okay? And then part C, we just go straight to graphing the function. But you need to have those three things. The y-intercept, the axis of symmetry, and the entire vertex. Just like,
So for the
look at example 2.
So for the entire vertex,
Look at example
it'd be
2.
the x and y.
Mm. Yes, the x and the y for entire vertex. Okay, go down to the bottom here. Determine whether each function has a maximum or a minimum. Okay, state which one. Which one? And then find that value. Then state the domain and range. So you got lots of steps. We need the domain and we need the range. Lots of steps of each one of these, right? That's why you have so few problems. Good? Going to the back side, it's the same instructions, so you can cancel out the B. You need to find the entire vertex, etc. Okay, use this information to graph the function. Same information down below, but you're only doing 2, 4, 6 on this page and nothing else. 2, 4, 6. There are not many problems. But what does that mean?
They're hard.
They're kind of harder, but also I expect you to do a good job to show your work and be very thorough. On this bottom part right here, this is look at example 3. If you need an example, look at example 3 on your notes. Look at example 3. Okay, the top, look at example 2. The bottom, look at example 3. The top, look at example 2. The bottom, look at the example 3. Good? Happy with that?
Yep.
Okay, you have time. Use your time to work.
I use it to study.